So to recap what we did last lesson, don't worry if you missed it. You should have caught up by now, even if you were in yesterday. But you don't need that for today's lesson, so you can always catch this up at another time. Any of the lessons we've done and you've missed because you've been in school, please make sure you do have caught up with the work. So this is what we were doing. We were simplifying kind of algebraic fractions when we've got division or multiplication involved. Remember the steps are factorise it. So I'm going to factorise this one, and I'm going to take x out the top to begin with, because that's all I can see that I can do. I've picked a rather tricky one, just so I've got just showing you a few things. Divided by, factorise the top of that one, and factorise the bottom of that one. It's going to be x minus 7 and x plus 2. I can actually simplify this a bit more, because I should see straight away that in the bracket I've got the difference of two squares. So that's actually x plus 1, x minus 1 over x plus 2. Now, I'm dividing by a fraction, so remember, when you're divided by a fraction, keep that first one the same, change that to a multiply, and flip this fraction. And then that's multiplying fraction is the easiest thing to do. So we're going to combine the top. Okay, and then we can just put all of those alongside each other. Right, and now I can do some cancelling down, because remember, the whole point is you should end up with these ones, when you're multiplying and dividing especially, you should end up with stuff that's going to cancel down. Here, this minus 1 and this minus 1 is going to disappear. This x plus 2 and this x plus 2 is going to disappear, and actually this x and this x is going to disappear. So I'm only left with x plus 1, x minus 7, and that is it. I've got nothing on the denominator at all, which is bizarre. As always, you should use substitution, so pick a value for x, put it in there, get a value, put it in there, and make sure you get the same value. So today we're going to be looking at extending this and start adding and subtracting algebraic fractions instead, which is a little bit trickier. So let's start off by just trying to remember how we add fractions normally. So if you remember, we have to make the denominator the same. You look for a number that both of those denominators go into, or, which is a skill that's going to help you a bit more this time, is I can get that number, I can just multiply these things together. So I can put them both over 15. Well, that top one, I multiplied that 3 by the 5. So I have to multiply the top by the 5, and I will get 10. The right-hand fraction, well, I've had to multiply that by 3. So I need to multiply the top by 3 as well to keep it equivalent, and I get 12. And I get 22 over 15. And I can convert it into a mixed number if I need to, or if the question's asked. Right, so let's try and apply the same idea to some algebraic ones. Let's have a look at this one to begin with. Well, so again, I need to make the denominator the same. I said up here on this first example that an easy way to do that is just actually by multiplying those two numbers together. It's not going to be the most efficient way, but it does work. So I can make the bottom xy, because that's the two multiplied together. So I'm following the same ideas. So just because it's algebra, people seem to forget that the same rules don't apply. They do, okay? We're just putting them over a common denominator. Well, and again, so this fraction here, I had to multiply the bottom by y, so I need to multiply the top by y. Here, I had to multiply the denominator by x, and so I'm going to have to multiply the top by x. Now I can just add the top. So once the denominators are the same, I can just add the tops. And that's how I leave it. I can't do any simplifying to that. That is as simple as it gets. So let's have a think about this one. It's actually a little bit easier because we've got no algebra down the bottom. Right, so I'm going to put these both over 6. I could have got that. I know that because 2 and 3 both go into 6, or you can just done that from multiplying those two things together to get that denominator. So I know it's going to be something over 6 minus something over 6. Well, this one I had to multiply by 3, so let's multiply the top by 3 as well to keep it equivalent. This one I had to multiply the top by 2, so to keep it equivalent, multiply the top by 2. Now I can combine the tops. So this, don't forget, it's a minus this time, over 6, and again that doesn't simplify, but we should check, but it doesn't this time. Right, so there's one. Again, same thing. I'm gonna just this time the denominator I'm going to turn it into 28 because that's because I know that. However, I could have got that or a common denominator just from multiplying those. Right, so that first one I've multiplied the bottom by 7, so I have to multiply the top by 7. And then other one is going to be over 28, and I've had to multiply the bottom by 4, so multiply the top by 4. Now I combine the tops because they are over the same denominator. And don't forget, if you can, that top we need to simplify. 7x plus 4x is 11x. And that's me done with that one. Nothing else happens to it. This one, well, actually, no, let's go through it. So again, let's just follow the same technique, right, that we were doing before. So let's work this out from multiplying these two things. Well, so I'm going to put them both over 24. Well, I'm going to have to multiply that left-hand side by 6. So I'm going to get 6a. And I multiply that one by 4, so let's do that to the top, 4b. So I end up with 6a plus 4b all over 24. Now, you should, again, always keep an eye out for things that are common to everything. So here, the top and bottoms, they're both all even stuff, so I can divide the top and bottom because it's just a fraction. I can divide the top and bottom, all of it by 2. So I get 3a plus 2b over 12, and I can't do any more from this. The alternative here is thinking about just having a bit more thought to think, okay, what is the common denominator of 4 and 6? Oh, okay, it's 12. So I can put them both over 12 to start with. So I would have to multiply that first one by 3. And I'd have to multiply to get that second one over 12. The second one by 2. And then I've skipped a step, if you like. It doesn't really matter. It would probably be better to stick for this routine for what's going to come up later. However, you've just got to remember to simplify. If you put this as your final answer, you're going to lose marks. Right, final one on this page, and then you can do some for practice. So here, again, let's do it both ways. So let's do it first of all by getting a common denominator just by multiplying those. So I'm going to put them both over 2e cubed. And don't forget, be very careful, it does say it's a minus. Well, that first one I have multiplied by e squared, so multiply the top by e squared. That second one I've multiplied by 2e, so multiply the top by 2e. Combine the tops. And obviously the denominator stay the same. And looking at that, you go, there are e's in everything. So divide the top and bottom completely, all of it by e. I get 3e minus 8 over 2e squared. Again, but alternatively, I could have spotted straight away. Well, look, to get these the same, I've got this as already contains e, so I don't need to multiply it, but I just need to multiply that one by the second one by 2. And so I'm going to multiply the first one by e, and the second to get e squared under both, and the right hand one by 2, and you would get 3e over 2e squared minus 8 over 2e squared, and I end up with the same thing over that I had before. No. end up with that anyway. But I reckon maybe stick to this. It's not the most efficient method, but as long as you're checking if you can simplify it, it's going to help us out next lesson. So please pause the video and have a go at these, and then once you've done, restart it and we'll go through the answers. Okay, so let's go through these answers. So here, let's put them both over 15. So I end up with 5x over 15 plus 3x over 15. So that is 8x over 15. 9c over 14 for B. So I get 6m over 16, but we need to divide the top and bottom by 2 to get it simpler. So that's 3m over 8. So here I'm going to make the denominator, I'm going to do it by multiplying these two things. So I'm going to have 3ac on the bottom. I have to multiply that first, fraction top and bottom by 3 for that to happen. The top and bottom of this second one by AC for that to happen. And you end up with 18 plus 2AC over 3AC, and I can't do anything to simplify it. 36 plus w squared x over 4w for E. D cubed plus 6 over 3d squared for F. You start to notice kind of patterns. You kind of go, right, it's this times this. Right, so that is 4m cubed. And this time it's minus this times this, so it's minus 54 over the 2 multiplied, 24m. And then simplify if you can. I can divide it all by 2. So I get 2m squared minus 27 all over 12m. So this technique does once you speed things up, it is quite useful. I do that times that, which gives me the 6b minus this times this, 4b squared all over these two multiplied, which is 8b cubed. Simplify it down. I can divide it all by 2. I'm going to do that. Let's do it step by step. Divide it all by 2. So I get 3b minus 2b squared all over 4b cubed. And I can divide it all by b. So I get 3 minus 2b, or not to be, over 4b squared. Again, I could have a simpler way to do that, or a more efficient way would have been to say, oh, I just need to multiply this one by 2b and the top and bottom by 2b, and then both the denominators would be 4b squared, a bit quicker. Over here, so it's ac squared plus 20 over 5c.